we will now be taking any questions.
I'm glad to see that you, in your written report, you did not include the dollar amount. I don't think I didn't see anything of that. And now you went over and can you be more specific about you mentioned a pilot project. Can you be more specific at what a pilot project would be and how do you be accomplishing that and the data that would be obtained and how that data would benefit you for implementing in any other locations?
Sure. So the way a pilot program would work, and this is fairly common amongst data analytics companies, you would go in and you would tell them your initial factors, what you want to get out of it. The pilot program would be for the central Cuban rice farms. So we would take one specific rice farm in central Cuba, and that would be the initial $5,000 cost. And then once that whole algorithm is developed for that one farm, we can then scale it up outwards. But it is important to note that the cost for implementing it in other farms would be progressively less and less because as we get more and more data, we don't need to collect as much for our solution to be implemented.
At this moment, how much of a production increase would you estimate that would be obtained after implementing this in the rice? Or is more than a preserving or increasing the production?
It's meant for increasing the production.
Okay.
And increasing Cuba's independence on crop and food staple reliance.
Okay.
Yeah. So additionally, the fact that the microcatchment results in, I think, 330 milliliters of the required millimeters, of rain of the required 714 millimeters for rice being accumulated and efficiently used. So it just means that Cuban farmers will have to use a lot less irrigation water or water, that actually costs them any sort of resources or money.
Okay.
And kind of just to add on to that, most irrigation systems that are in place right now require a lot of manpower and skill to be able to implement the pipes and the drainage systems and everything. And this also changes the salinity of the soil, which makes it less fertile for crops later on. The good thing about a microcatchment is it's very natural. So you're contouring the land as it is. You're not changing the composition of the soil, and it retains its fertility. So the fertility of the soil and the amount of crop production doesn't decrease as a result of whatever new irrigation that we have. So that's one advantage of our system.
Basically, what you propose is to have reservoirs or open cisterns adjacent to the fields where the crop will be planted, let's say in this case, rice. So, but rice has been imported by the Spaniards from Asia. Perhaps rice is not the best crop to plant in Cuba. And assuming, if you have this fixed idea that you need to have rice, because actually it became a staple of the Cuban diet. But that is because the Spaniards brought it from Asia. Perhaps we should have something else. And Cuba has two extremes. It has this amount of rain coming from all these tropical storms on one side, and then the lack of it. So wouldn't these open reservoirs be flooded in any type of rain, and then the soil will be absorbing most of it or evaporating before it could be used?
So our initial plan didn't include the cisterns, but it could. The point of the microcatchment system is that the collection is not the only part that's important. While it's running off, the water table also rises in the water under the soil. So the profile of the soil has been adjusted now. So it kind of naturally absorbs a lot of the extra water that you're talking about happens from floods and tropical storms.
So it'd be more like for a flood prevention type of situation, be at least flood regulating type of element.
It helps with soil erosion, but not flood prevention specifically. This is just to kind of redirect water so that it doesn't collect. It can help with flood prevention as a side effect, but we were talking about it more in terms of production and clean water required to produce the crops.
And just to comment on what you said about the rice, the reason we looked at rice is because we found that it was a very important staple. Rice and beans is probably one of the most common Cuban dishes. It's something I grew up with a lot as a kid. So we figured if we could increase, say, rice or bean production, we could have the greatest impact in feeding Cubans. But it's very possible to switch to a different crop if when, say, going to Cuba and investigating the situation further, we found that something like tobacco or sugarcane would be more feasible.
Yeah, like in Uruguay, everybody drinks mate, and it doesn't grow there, so it's imported. So it could be, the rice would be imported for where it's more efficient, and something else that is more appropriate for that thing, from that land.
Right. Rice is only our initial pilot project, and through the algorithms and the big data analytics, we're hoping to expand towards other crops. But we can start with a different crop if it's more suitable.
So why exactly do you need the internet?
Sorry, can you say that?
Why do you need the internet? Why do you need this connected to the internet?
The farmers need to upload the data that they've collected, that the probes have collected from their farms, in order for it to be analyzed by our algorithms.
So you're planning to have the algorithms probably on the cloud doing the job for the farmers, right? But again, being practical, there is barely internet in Cuba, and farmers don't even have access to signal to talk on a cell phone. So how can you propose a solution to someone that doesn't have access to internet at all?
Yeah, another option is to have the server or the data run on the island. The reason we went with internet is because we know that a lot of data analytics companies are housed here in Miami, and we found that if we could find a place with access to internet, that would be the easiest way to run our initial pilot program. But it would be possible to have a server housed in Cuba to make it easier to transmit the data.
If you want to be practical, if you want to give a real solution, you need to think about real problems. And having data being transferred from Cuba to the United States is actually not possible. And no one in the government is going to welcome that. So you need to think about how can you give the resources to the farmers so they can analyze data and have the result right there, not even waiting for someone else to send the result back and what to do.
Yeah, another thing we could do is once, having an algorithm set up, we could have that essentially embedded into the program so that it runs right off of the farmer's laptop or something of that sort.
One of the things that I saw in the written paper was that you expected the farmers to provide the data, if you will, and that, I'm assuming that's through the use of the sensors that you're proposing. Farmers are by and large in Cuba anyway. They're humble, not necessarily highly educated people. So is there anything associated with the use of the sensors that would be difficult for them to do? Or is it something as simple as they just install a probe, et cetera? And second, also related to that, who will be running these drones and what would the drones be doing? Just getting data from the sensors, et cetera?
Yeah, so I was actually going to start with the drones. Flying the drones might be the most complicated thing, I would say. If a farmer were not skilled enough, then we would need some sort of person who is more tech savvy. As far as probes, there are probes that you just stick in the ground and they give out sensor data. For example, there is one that'll measure the, how arid the soil is, and that's just a matter of putting it over whatever plot of soil you want to examine and letting it run.
A lot of the sensor data as well is already available. Some of the groups before us actually talked about it, especially for salinity. That's very easy to do. There's already collection points in place in Cuba at the moment that takes care of like what the soil profile looks like and what the standing water level is. If you've heard of the hand method, which is the height above the nearest drain, that's another. There's a lot of things already in place. So what we're suggesting is not that we install a whole bunch of new sensors and start from scratch. It's to already use the data that we have and kind of implement it and use it to perfect this microcatchment system that the farmers will be able to use. So a lot of the data they don't have to personally provide. It might just be where am I located geographically, what's the aridity of my soil, and what's the salinity, and that's like two simple sensors as opposed to them having to fly drones.
Okay, the cost of the data analytics that you provided are fairly low cost, if you will, for data analysis, but for Cuba they're still significant. Are there any other companies who can do this data analytics, or is it limited to this one company, or is this just one sample that you guys had?
No, this company, we actually just spoke to them to see what it was like, what the cost range was like in the industry. So we can very various different companies to see if there's anything that's cheaper. We just wanted to get a rough estimate so we could decide whether or not this was potentially feasible.
Thank you. Thank you.
Thank you. At this time, we're going to take a 5-minute break and come back here at 10:45 to resume the live webcast. So we're going to take a 5-minute break to stretch, and we'll be back here in 5. Thank you.